We will start with trigonometric identities. So there are three identities that we need to do in this chapter. So we have sine square theta plus cos square theta equal to 1. Then 1 plus tan square theta equal to sec square theta. And 1 plus cot square theta equal to cosec square theta. So for this I'll take a right angle triangle. Let's say I have a right angle triangle ABC, right angled at B. Let this side be equal to x, this is y, and this is z. Now we'll start with the first one, that is to prove that sine square theta plus cos square theta is 1. So in my LHS I have sine square theta plus cos square theta. So sine square theta is given by opposite side to the by hypotenuse. So I'll take this as theta. So the side opposite to theta is x and the hypotenuse is z. So it is whole square plus what is cos? Cos is adjacent by the hypotenuse. So that's y by z the whole square. So opening the brackets, this would be x square by z square plus y square by z square. Since the denominators are same, I can write this as y square plus x square whole thing by z square. Now since ABC is a right angle triangle, by Pythagoras theorem I have x square plus y square equal to z square. The sum of the square of two sides is equal to the sum of the square of the hypotenuse. Hypotenuse is the side opposite to 90 degree. So x square plus y square is equal to z square. So z square by z square. So this becomes equal to 1, cancelling out. So my RHS is 1. So if we observe from my equation, let's call it 2 and 3, from equation 2 and 3 LHS equal to RHS. So we have proved sine square theta plus cos square theta equal to 1. So the next is 1 plus tan square theta equal to sec square theta. So I have redrawn the triangle over here. So the next identity that we need to prove was 1 plus tan square theta equal to sec square theta. So I'll start with my LHS. LHS is 1 plus tan square theta. 1 as it is, tan is, okay, let's take this as theta. Tan is given by opposite by the adjacent. So opposite to theta is x and adjacent to theta is y. So 1 plus x by y whole square is 1 plus x square by y square. Taking the LCM, I have y square plus x square by y square. We just saw that x square plus y square is nothing but z square. Z square by y square, which I can write as z by y the whole square. Now what about my RHS? In my RHS I have sec square theta. Sec is reciprocal of cos, so it is given by hypotenuse by the adjacent side. So it is z by y the whole square. So by equation 1 and 2 we have proved that LHS equal to RHS. Now we move on to the third identity. So this is my third identity, 1 plus cot square theta equal to cosec square theta. We will start with the left hand side. So my LHS is 1 plus cot square theta. So 1 plus cot is given by adjacent by the hypotenuse. Little mess up here. Yeah. So adjacent over here is cot is given by adjacent by the opposite side. So y by x the whole square, which is 1 plus y square by x square. Now taking the LCM, x square plus y square by x square. Now x square plus y square is nothing but z square. We just saw that. So I have z square by x square. I can rewrite this as z by x the whole square. So that's my LHS. Now RHS is cosec theta. So over here I think some little mess up happened. So this is cosec square. Okay, so cosec theta is given as cosec square theta. Cosec is nothing but the reciprocal of sine, which is hypotenuse by the opposite. So hypotenuse is z by x the whole square. So by equation 1 and 2, we have LHS equal to RHS. So we have 1 plus cos square theta equal to cosec square theta. So let's rewrite all our three identities that we have done today. So we have sine square theta plus cos square theta equal to 1. We have 1 plus tan square theta equal to sec square theta, and we have 1 plus cot square theta equal to cosec square theta. So we'll see questions related to these identities now. So this is the question that's given to us. Sine square 63 degrees plus sine square 27 degrees by cos square 17 degrees plus cos square 73 degrees. Now when I see square over here, it relates me back to sine square plus cos square identity, and I can see that I have complementary angles here. So I'll convert one sine to cos. So I have sine square 63 degrees plus we know that sine theta is equal to cos 90 minus theta. So this can be written as cos square 90 minus 27 degrees. Okay, and over here I'll convert this to sine. So I have cos square 17 degrees plus sine square. We know that cos theta is equal to sine 90 minus theta. Theta here, whatever is cos of the angle. So that's 73 degrees over here. So 90 minus 73 degrees. So let's write down sine square 63 degrees plus this becomes cos square 63 degrees. Cos square 63 degrees by cos square 17 degrees plus this becomes sine square 17 degrees. Now we know sine square plus cos square is equal to 1. Sine square theta plus cos square theta, when the theta has to be same in that. When I'm using the identity sine square theta plus cos square theta equal to 1, this theta has to be same. So I'm using the identity over here. So 63 degrees and 63 degrees. So this is equal to 1. Similarly, I have sine square theta plus cos square theta, where theta over here is 17 degrees. So that is also equal to 1. So hence the answer is 1. So this is the next question. When I see 25 and 65 are complementary angles, you can check here, 65 plus 25 gives me 90 degrees. So they are complementary angles, and I can see that this is product form. So I'll try to bring it to sine square plus cos square. So if I have to bring it to sine square plus cos square, my theta has to be same, because the formula is sine square theta plus cos square theta. So this theta has to be same. So I will keep this as 25. So I'll change all angles to 25. So this complementary would be sine 90 minus 65 degrees. Plus, as I said, I'll keep all angles to 25. You can try it out with 65. So cos 25, this sine is cos 90 minus 65 degrees. So this is sine 25 degrees. Sine 90 minus 65 would become sine 25 degrees. So that's a dot here is product. Plus cos 25 degrees. This would be cos 25 degrees. So this becomes sine square 25 degrees. Sine 25 into sine 25 is sine square 25 degrees plus cos square 25 degrees. Now we know sine square theta plus cos square theta is equal to 1. The angle has to be same. In this case, it's 25. So this is equal to 1. So this is my next question. So I see that I have sec square and tan square. So immediate thought that I get is, see the identity involving tan and sec. So we know that 1 plus tan square theta is equal to sec square theta. So sec square theta is 1 plus tan square theta. I'll use that over here, 9. Sec square a can be written as 1 plus tan square a using this identity. minus 9 tan square A. Opening the brackets, 9 into 1 gives me 9. 9 into tan square gives me plus 9 tan square A minus 9 tan square A. So when we have two same things with opposite sign, they cancel out each other because the value is equal to 0. So this thing is equal to 9. So this is the next question. Now immediately when I see this, I'm not seeing any identities because I'm not seeing a square over here. So what I will try to do over here is, I'll convert everything in terms of sine and cos. That's the easiest approach I feel. When you don't see a direct identity, is convert everything in terms of sine and cos. Tan theta I know is sine theta by cos theta. And sec theta is nothing but 1 by cos theta. The whole thing into 1 plus cot theta is cos theta by sine theta minus cosec is 1 by sine theta. So the LCM over here is cos theta. So I'll multiply this term with cos theta. So we have cos theta plus sine theta plus 1 by cos theta into, here the LCM is sine theta. So I'll multiply this with sine theta. Sine theta plus cos theta minus 1 by sine theta. Now, over here, if let's say I have two numbers, two fractions or rational numbers, a by b into c by d, this is same as a into c by b into d. So I'll use that over here. So my denominator would be cos theta into sine theta. Okay, here it will be cos theta plus sine theta. I'll group this as 1 plus 1 into cos theta plus sine theta minus 1. So if we observe, this is of the form a plus b into a minus b, which is a square minus b square. So a over here is cos theta plus sine theta whole square minus 1. Okay, by cos theta into sine theta. Because see, if you consider this whole term as 1, this is of the form a plus b, if this is b, into a minus b over here, which is a square, that is the first term whole square minus the second term whole square. 1 square can be written as 1. So now expanding this using the formula a plus b the whole square, which is a square plus b square plus 2ab. So I have a square cos square theta plus sine square theta, that's my b square, plus 2ab minus 1 by cos theta into sine theta. Now cos square theta plus sine square theta is equal to 1. So the value of sine square plus cos square theta using the identity cos square theta plus sine square theta is 1 plus 2 sine theta cos theta or cos theta sine theta. Okay, I just wrote sine theta first. Sine theta cos theta minus 1 by cos theta into sine theta. Now, two values are same but the signs are opposite, so they cancel out each other. So I am left with 2 sine theta cos theta by, I can write this as sine theta into cos theta. So they cancel out each other and the answer is 2. So the value of this question is 2. So this is my next question. Ck plus tan A into 1 minus sine A is equal to which of these following? So as I said, the easiest approach when I am not seeing a direct formula is to convert into sine and cos, unless there will be few special questions where it helps not to convert. So we will discuss those. So over here sec is nothing but 1 by cos A and tan is sine by cos. So this would be sine A by cos A, okay, into 1 minus sine A. So if there's no denominator, that means the denominator is 1. So here, since the denominators are same, they are like terms, I can add the numerator. So 1 plus sine A. Okay, this is product form. So 1 minus sine A. Now this is again of the form 1 plus A plus B into A minus B. We know that A plus B into A minus B is A square minus B square. So this is 1 minus sine square A by cos A. So I have the formula sine square theta plus cos square theta equal to 1. Now what happens if I shift cos square there? I have 1 minus cos square theta equal to sine square theta. And similarly, if I shift sine over there, I have 1 minus sine square theta equal to cos square theta. So this is the different forms I can write the same identity in. So here I will use that 1 minus sine square A is equal to cos square A. Here the angle is theta, here the angle is in terms of A. So that's equal to cos square A by cos A. So it's similar to x square by x, it cancelled out and we have just x. So this will cancel out and this would be equal to cos A. So the answer over here would be cos A, that is D. So this is the next question, 1 plus tan square A by 1 plus cot square A. So this is directly identity. So 1 plus tan square A is given as sec square A by 1 plus cot square A is cosec square A. So sec square is 1 by cos square A and cosec is 1 by sine square A. So division is nothing but inverse multiplication. So it's 1 by cos square A into sine square A by 1. So sine square A by cos square A, which is nothing but tan square A. So that's our answer, equal to tan square A. This is our next question. So I do not see a direct identity. So what I will do is I'll take my LHS. We have to prove that this side cosec theta minus cos theta whole square is equal to 1 minus cos theta by 1 plus cos theta. So I'll start with my LHS. So I have in the LHS cosec theta minus cot theta whole square. Now what I'll do is I'll convert everything in terms of sine and cos. Cosec is 1 by sine theta minus cot is cos theta by sine theta whole square. So since the denominators are same, the terms are like, I can add or subtract my numerator. So I have 1 minus cos theta whole square, which can be written as 1 minus cos theta whole square by sine square theta. We know the identity that sine square theta is 1 minus cos square theta. We just saw in the previous section. So over here 1 minus cos theta whole square, I will write sine square as 1 minus cos square theta. Now this is of the form A minus B the whole square. A square minus B square. One square I can have here, which is A plus B into A minus B. So it is 1 minus cos theta whole square by 1 plus cos theta. Since it's of the form A square minus B square, which is A plus B. A is 1, B is cos theta, into A minus B. So over here this and this will get cancelled and I will have 1 minus cos theta by 1 plus cos theta, which is our required result, because I had to prove that this is equal to 1 minus cos theta by 1 plus cos theta. This is my next question. Cos A by 1 plus sine A plus 1 plus sine A by cos A equal to 2 sec A. Now what I will do here is I'll take the LCM. So I'll start with my LHS and I'll take the LCM. LCM would be 1 plus sine A into cos A. So this term will be multiplied with cos square A, and this term would be multiplied by 1 plus sine A. So already there was a cos A, so when it's again multiplied with cos A, it becomes cos square A. There was already a 1 plus sine A, so when it's multiplied with 1 plus sine A again, it becomes 1 plus sine A the whole square. Now this will be cos square A. I will open this, I will expand this using the formula A plus B the whole square, which is A square plus B square plus 2AB. So this would be 1 square is 1 plus sine square A plus 2AB. So sine A into 1, so that would be just 2 sine A. Whole thing by 1 plus sine A into cos A. So as far as possible, I avoid opening anything in the denominator. So I have cos square A plus sine square A, rewriting it, plus 1 plus 2 sine A. Whole thing by 1 plus sine A into cos A. So see where it actually leads before, just opening up all the brackets and everything. Step by step. So sine square plus cos square is 1. I have one more 1 here, plus 2 sine A. I'll keep the denominator as it is. So 1 plus sine A into cos A. So 1 plus 1 would become 2. 2 plus 2 sine A by 1 plus sine A into cos A. I will take 2 common over here. So when I take 2 common here, if I want, I can write this as 2 into 1. So if 2 is gone, what is left here? 1 plus sine A by 1 plus sine A into cos A. So this and this will get cancelled. We know that 1 by cos theta is sec theta. So this becomes equal to 2 sec A, which is our required result. So we have to prove is equal to 2 sec A. So I'll stop this video over here with these questions. We'll do many more questions based on these 3 identities in the coming videos.